expressing concentration. So our objectives for today, at the end of this section, you should be able to use different ways of expressing concentration of solutions. So we are going to discuss percent by mass, percent by volume, molarity, and molality. Number two, choose the appropriate unit of concentrations to use in these calculations. All right. So our first way of expressing concentrations is the present by mass. Okay, as you can see in our slide, we have here the formula. Percent by mass equals mass of solute divided by mass of solute plus mass of solvent. So mass of solute and mass of solvent is also known as the mass of solution. So these two, you will multiply it by 100%. Okay. So if you can measure the masses of the solute and the solution, determining the mass percent is easy. So each mass must be expressed in the same units to determine the proper concentration. So let us try answering this problem. So suppose that a solution was prepared by dissolving 25 grams of sugar into 100 grams of water. So let us substitute it in our formula. So we have percent by mass equals, the mass of solute is 25 grams. All right, so we need to divide that to the mass of solution. So we can add directly the mass of solute and mass of solvent. That will result to 125 grams. Then we need to multiply it by 100. Okay, so we have here the same units. So that is, this one is division. So let us cancel out the same unit and proceed with the solution, the computation. So we have 25 divided by 125 times 100. Our percent by mass is 20%. So this is our percent by mass. Moving forward to our next problem. All right. So we have a saline solution with a mass of 355 grams, has 36.5 grams of sodium chloride dissolved in it. So which means that the sodium chloride is our solute because this one is dissolved. So 36.5 is our mass of solute. Then 355 grams is our mass of solution. So let us now proceed with the substituting it to the formula. So the mass of solute is 36.5 grams divided by our mass of solution, which is 355 grams, multiplied by 100%. Okay. Cancel out the same unit. Now let us compute 36.5 divided by 355 times 100. Our answer is 10.28%. So this is the percent by mass of our solution. All right. Next, let us proceed with our second, expressing concentration. So our second way is percent by volume. So in this case, we are going to use the volume of the solute and the volume of the solution. Okay, and we will also multiply it by 100 to get its percent by volume. So determine the volume percent solution made by combining 25 ml of ethanol with enough water to produce 200 ml of solution. So in our problem, the volume of solute is the 25 ml of solution, and this one is the volume of our solution. Sorry, again, the 25 ml of ethanol is our volume of solute, okay? And our 200 ml is the volume of solution. Let us substitute this. Percent volume equals volume of solute is 25 ml over the volume of solution, which is 200 ml. We need to multiply it also by 100%. So our answer, 25 divided by 200 times 100%, that is 12.5. Cancel out the same unit, and yung naiwang unit is percent sign. So our volume percent volume is 12.5%. Moving forward, second problem for percent by volume. So a solution is prepared by dissolving 90 ml of hydrogen peroxide in enough water to make 3,000 ml of solution. So identify the concentration of the hydrogen peroxide solution. So let us have percent by volume. So our volume of solute is 90 ml. Divide by our volume of solution. So this is our volume of solution, that is 3,000 ml. Multiply by 100%. Okay? Now, let us cancel out the same unit. 90 times, or 90 divided by 3,000 times 100, we will get 3%. So our volume for this solution, or our percent by volume, is 3%. So the third one is the molarity. So in using this way, we need to look for the solute, and the solute must be in moles, no? And our solution must be in liters. Okay. So for example, our solution is in ml or gallons. Yan. So we need first to convert this into liters before proceeding with our formula. All right? So now, let us answer this problem. Determine the molarity of the following solution. So we have 0.444 mole of COCl2. And the liter of solution is 0.654. Okay? Now, let us solve for its molarity. So you need to write the moles of solute in the upper part. So let us write 0.444 moles over the liter of solution, which is 0.654 liters. All right. Now, let us proceed with the operation, which is division. So you need to multiply, or rather to divide 0.444 and 0.654. So let us proceed. So our answer is 0.678 mole per liter. So this is the molarity concentration of our solution. And its unit is in mole per liter. Okay, so for our next problem for molarity, determine the molarity of the following solution. So we have 1.457 mole of potassium chloride in 1.5 liter of solution. So our formula is you need to divide moles of solute and liter of solution. So let us solve. 1.457 mole over the liter of solution, which is 1.5 liters. Now let us proceed with division. 1.457 divided by 1.5, the answer is 0.97 mole per liter. So this is our answer. Next, for our molality. Okay, so for molality, we also have the solute in moles, no? As you can see, it is just like the molarity. We also use the moles of solute. But for the solution, it must be in kilograms. For instance, if the solution given in your problem is in grams or pounds, no, you need to convert it first to kilogram before proceeding to the formula. Okay? Now, let us answer this problem. So, we have 3 moles of sodium chloride dissolved in 2 kilograms of water. So, let us have the molality. Write 3 moles over 2 kilograms. And our answer is 3 over, or 3 divided by 2 is 1.5. And our unit for molality is mole per kilogram. So this is the concentration of our solution. And for the final example for the molality, okay, so as you can see, we have listed here the given. So we have the moles of sodium chloride, which is 0.086 mole. And the mass of water is 0.250 kilogram. Okay, so let us substitute it in our formula. So our formula, um, moles of solute, which is 0.086 mole over the kilogram of solution. So we have 0.0250 kilogram. Right. So now let us compute. 0.086 mole divided by 0.0250 kilogram. The answer is 3.44 mole per kilogram. So this is the concentration of our solution.